This week is mostly about indexing. And then at the very end of the week, we're going to talk about sharding, which is distributing database queries across multiple servers. But before we do that, we need to introduce you to the idea of what a storage engine is inside the database. Because this was a big year for MongoDB. New in MongoDB 3.0 is that we offer pluggable storage engines. Now, what is a storage engine? A storage engine is the interface between the persistent storage, which we'll call the disks, which might be a solid-state disk, and the database itself, MongoDB. And this is the MongoDB server. So the MongoDB server talks to the disk, the persistent storage, through a storage engine. So that's the storage engine right there. And you, the programmer, you're going to be writing, let's say, a Python program. And so you'll be writing in Python, and it'll be using the PyMongo driver, which talks to the database server using the wire protocol. And when it wants to create data, read data, update, and delete data, it'll talk to the storage engine, which will then talk to the disk. And all the different structures that hold the documents, that hold the indexes, and the metadata involving the documents are all written to the persistent storage by this storage engine. Now, it may be the case that the storage engine itself decides to use memory to optimize the process. So in other words, the disk is really slow. So since the idea of a database is to store stuff persistently, what happens is the storage engine has control of memory on your computer, and it can decide what to put in memory and what to take out of memory and what to persist to disk and when. So the database server itself defers the handling of the memory on the server as well as the disk itself to the storage engine. Now, we offer a pluggable storage engine architecture where you can use more than one. The idea here is that, let's say you had a car and you wanted to have different engines, you could put the engine in the car, and then it would probably change the car's performance characteristics. For instance, it might accelerate faster or it might get better or worse gas mileage because of the type of engine you put into your car. And similarly, depending on the type of engine that you put into MongoDB, you're going to get different performance characteristics. And that's why it's important that we have some basic understanding of this before we move on to this week. There are two main storage engines that ship with MongoDB that we support, and one of them is called mmap, and the other one is called WiredTiger. Mmap is the default. It's what you'll get if you don't give any options to MongoDB when you start at the command line. And mmap, we're going to go through how this works. It's been the storage engine for quite a while. WiredTiger came in through acquisition in 2014. MongoDB acquired the WiredTiger company. This is the same team that built BerkeleyDB, and also a lot of them were at the company SleepyCat, if you know your computer history. All right, so now you have some basic understanding of what a storage engine is. So what is the storage engine not? What are some of the things that a storage engine doesn't handle? Well, if you have a bunch of MongoDB servers all running in a cluster, the storage engine doesn't affect the communication between those different MongoDB servers. And the storage engine doesn't affect the API that the database presents to the programmer, for example. It's the same pretty much whether or not you use mmap or WiredTiger. But there are going to be some differences in performance, and that's why we're going to discuss it. All right, now it's time for a quiz. The storage engine directly determines which of the following. Check all that apply. The data file format, architecture of a cluster, the wire protocol for the drivers, and the format of the indexes. I didn't directly talk about some of these, so you might have to guess based on what I said.